Welcome to ultraviolet UV and ultrafiltration UF. On the filtration spectrum, ultrafiltration lies right here, slightly above reverse osmosis, and it is used to remove fine particulate from the water down to 0.025 microns, which puts it down in this range where it's able to remove nearly all viruses from the water, colloidal silica, gelatin, even endotoxins, like in the case of Columbus, Ohio, last year with the blue-green algae bloom that got sucked into their intake system of their water treatment plant. UF would reject that toxin in that case. Now, what is an ultrafilter? It's a mechanical separation process down as low as 0.025 micron, and it's a membrane-like technology, excellent for removal of suspended solids, high turbidity loads, and high silt density, and aluminum sulfate is a flocculant. And it's great for those highly turbid waters and surface water sources. I can think of the Mississippi River, the lower expanses of it. They do not remove TDS or ionic contaminants such as chloride and silica, etc. Those are too small and need to be handled with reverse osmosis. But this will handle all the heavy particulate load from the water and remove quite a few organics from the water based on molecular size as well. Now, what the membrane, UF membrane actually looks like, these are the pores that the water has to go through that will strain out most of the molecules. This is a cross-section of one of the tubes that the water flows down and out, and this is actually the surface in between here and the outside wall of one of these tubes. And you can see the porosity. This is what this material is made up of, and it has to penetrate and come out the core. So water comes in, pushes out and through, and is strained out through that tangle of pores and pockets. How this works, you can see the water, raw water flows in. The debris is trapped on the inner skin separation layer with the smallest openings. They're preventing debris from being trapped or lodged deep in the capillary walls of this tube. So that these are capped at the end, but when it comes time to backwash the filter, it's going to open this up and allow it to flush through. And that's one of the nice qualities of a UF filter, is that it's self-flushing, able to prolong the life of it. And the Endurance SC version of our system is managed by a gallon meter versus a time clock in flushing this, and that gives you a very accurate way to adjust the flush cycles of the system to the customer's dirt load on site, so we're not wasting water flushing the unit too frequently. And the system cleans itself by opening a drain valve and flushing rapidly water from that's been already processed from a tank, stored, and flushing backwards. It can be done with raw water, but it's more effective with filtered water to flush that debris off the skin of the separation core of the UF membrane. The Endurance SC comes with a UF pre-filter with a programmable control that has gallon settings, allowing you to set the gallon flush cycle based on the incoming dirt load of the water. Comes with its own accumulator tank for storing filtered water, still chlorinated, because it hasn't gone through the carbon filters yet, to use as backflush or as a partial surge tank for flow out to applications. It comes with a 3/4-inch check line outlet for fountain applications and non-phosphate, such as drinking water applications, and a port with a 2SRBW phosphate feed system that will be fed to coffee, tea, espresso, and ice, and possibly boiler-based steam applications as well. It has four carbon filters for high volume, high flow rate applications to meet the demand of our customers. A lot of these systems are placed on moderate dirt load waters with very high volume use, simply that the load of dirt coming in is quickly following carbon filters or pre-filters to a point, and ultrafilter makes sense based on the volume of water that a customer uses, or they're used in areas with high dirt load or high use of flocculants, and the UF cartridge will help protect the carbon filters behind them from following from heavy dirt load or flocculants. Now, the offering overview, they come in a range of the sizes of a twin up to a quad system with capacities of 100,000 gallons up to 200,000 gallons and flow rates from 7.5 GPM up to 15 GPM. The UF cartridges are replaceable, and so are the cartridge kits, and they're separate, so they can be ordered separately. In the case of the membrane, due to very challenging water, allows them to be replaced on a separate schedule. The Endurance SC competitively is a very, very strong product. Only one other system out there is matched it in volume. Most others, it greatly exceeds it. And with the gallon flush, one of the most water efficient versions of this on the market, fits in a smaller envelope than our standard high flow CSR quad, and will fit essentially in a very similar envelope, only slightly bigger than the AJ and Tunis version of this system. Difference is we have quick change sanitary cartridge changeouts, while we're dealing with bowl style version changeouts with AJ and Tunis. Ultraviolet technology, or UV, when it is used, when there is a concern about virus, bacteria, or other microbiological contaminants in the water supply. What is it? Well, it's a disinfection technology, and that is different than a sanitation technology. Disinfection will kill bacteria and viruses, but it will not leave a residual or something behind to ensure of that. Chlorine is a sanitizer because we're able to create a reserve in the water or a residual that is there to work in case of reinfection, whereas a disinfection technology just kills whatever gets through. And it is used as an alternative to chlorination, where chlorination may be difficult or not very friendly to back-of-house environment. It is also typically used post-filtration because the organism that's designed to kill and the viruses may be able to hide behind turbidity particles or dirt particles in the water, just the way you can hide behind the shadow of something else if you're smaller than it. So if you can stay in the shadow of this big, relatively big ball of dirt moving down the water stream and you're a virus and that UV light never hits you, it will never deactivate you or disinfect you. So we want to use this technology post-filtration so that we have it maximize its effect killing bacteria and viruses and other microbiological contaminants. And how it works is light travels in two ways, in a wavelength and a photon. Wavelength, it has that energy associated with it, but with a photon it has sort of a mass, so it has the ability to impact things. So the energy involved from the wavelength traveling particle photon hammers into the dimers on the DNA chain, breaking them and deactivating them. So the organism cannot reproduce. So this virus is going, or bacteria will be extremely short-lived, die, and never make another one. So that way you stop any of that activity going forward. So that's how UV works.